June 1944. A sergeant named Curtis Cullen welded scrap iron to the front of a Sherman tank, and nobody thought it would matter. The beaches were won. 5,000 ships had delivered 150,000 men onto French soil in a single day, and by the second week of June, the Allies held a toehold 30 miles wide and 10 miles deep. But beyond the coastal dunes lay the bocage, ancient hedgerows 8 feet tall, root systems deeper than a man, earthen walls topped with bramble and thorn, dividing every field into a medieval maze. The Sherman tank, 30 tons of welded steel, 5 crew and a 75mm gun, was built for speed and open ground. In the bocage it was a sitting target. Every hedge hid a German machine gun nest or anti-tank crew. Every sunken lane was a kill zone. When a Sherman tried to climb a hedgerow, its thin belly armor tilted skyward, exposed. A single Panzerfaust round could punch through and ignite the fuel or ammunition. The crews called them Ronsons, lit first time every time. Between June 6th and June 30th, the First Army lost 766 tanks in Normandy. Not all were total losses, but many burned and the bocage kept bleeding them. The hedgerows themselves were older than the war, older than tanks. Some dated back to Roman occupation. 2,000 years of growth had created barriers more formidable than concrete. The roots interlocked like rebar. The earth was compressed by centuries of rain and cultivation. When a Sherman tried to push through, it didn't break the hedge. It climbed it. And climbing meant dying. The German defenders understood the terrain perfectly. They had occupied France for 4 years. They knew every lane, every field, every sight line. They positioned their anti-tank guns to cover the gaps between hedgerows. They placed machine guns to sweep the approaches. They mined the obvious routes and waited. When a Sherman crested a hedgerow, it exposed its belly for 3 or 4 seconds. That was enough. A Panzerfaust team could fire from 100 yards. A concealed Pak-40 anti-tank gun could fire from 500. Either way, the Sherman's thin ventral armor, less than an inch in most places, offered no protection. If the first round didn't kill the crew, the fire did. Sherman tanks used gasoline engines, high-octane aviation fuel. When a penetrating round ignited the fuel tank or sparked the ammunition, the interior became an incinerator in seconds. Crews had maybe 10 seconds to bail out, often less. Survival rates for knocked-out Shermans were grim. Roughly 40% of crews caught in a burning tank died before they could escape. The crews knew the odds. They kept fighting anyway. By mid-June, American commanders faced a tactical deadlock. Infantry advances were measured in hundreds of yards per day. Casualties mounted. The breakout toward Paris, planned for early July, looked impossible unless the Shermans could punch through hedgerows without exposing themselves. Engineers tried everything: explosive charges to blow gaps, bulldozers mounted on tank hulls. Neither worked well under fire. Explosive breaching required engineers to approach the hedgerow on foot, place charges, retreat, and detonate. Under fire, that process took minutes. Men died. And even when the charges worked, the blast created a smoking gap that told every German gunner exactly where the next tank would appear. Bulldozer tanks were better, but they were slow, vulnerable. The blade blocked the bow gun and restricted visibility, and there weren't enough of them. The entire First Army had fewer than 30 armored bulldozers. In late June, tank commanders improvised. Some tried ramming hedgerows at full speed. The result was usually a broken transmission or a stuck tank. Others tried firing high-explosive shells into the base of a hedgerow to collapse it. That worked occasionally, but it consumed ammunition and took time. Time meant exposure. Exposure meant casualties. The problem wasn't courage or firepower. It was geometry. The Sherman couldn't breach a hedgerow without lifting its nose. And lifting its nose meant death. Then a sergeant from the 102nd Cavalry Reconnaissance Squadron had an idea. Curtis G. Cullen was not an engineer. He was a tanker, 26 years old, raised in Cranford, New Jersey, drafted in 1942. By D-Day, he had spent 2 years learning how a Sherman moved, how it broke, and how it died. And he had spent 2 weeks watching good crews burn in the hedgerows. Cullen was a mechanic before the war. He understood torque and stress and leverage. He knew how machines failed, and he knew that the Sherman's problem wasn't power. It was angle of attack. The tank had enough force to push through a hedgerow. It just needed to apply that force horizontally instead of vertically. Cullen's idea was simple: weld steel teeth to the front of the tank. Let the tank cut through the hedgerow like a plow through dirt. He scrounged angle iron from a destroyed German beach obstacle. The Germans had planted thousands of steel hedgehogs and gate obstacles along the waterline to stop landing craft. After the invasion, those obstacles became scrap. Most were left to rust, but Cullen saw them as raw material. He cut 4 prongs from a hedgehog frame. Each prong was roughly 4 feet long, 2 inches thick. He shaped them into a fork pattern. 2 outer prongs angled outward, 2 inner prongs parallel. He welded the assembly to the lower glacis plate of a Sherman, just below the bow machine gun. The whole device weighed maybe 250 pounds. Crude, asymmetrical. It looked like something cobbled together in a farmyard. When Cullen demonstrated the prototype to his company, men laughed. Makeshift, jury-rigged, an improvisation that belonged on a tractor, not a combat vehicle. One lieutenant asked if Cullen was planning to plow a field or fight a war. But the first test was conducted on June 19th near Carentan. The Sherman approached a hedgerow at walking speed. The prongs bit into earth en route. The engine growled, tracks churned, the tank shoved forward, and the hedgerow split open like torn fabric. The Sherman drove through without tilting. Its belly stayed low, its gun stayed level, and it emerged on the far side of the hedge in under 30 seconds. No exposure, no pause, no kill zone. The crew stopped laughing. Word spread fast. Within 2 days, every tanker in the 102nd Cavalry knew about Cullen's hedgerow cutter. Within 4 days, word reached divisional headquarters. By June 21st, General Omar Bradley, commander of the First Army, visited the field workshop where Cullen and a handful of mechanics were fitting the device to more Shermans. Bradley was a pragmatist. He didn't care if a solution was elegant or official. He cared if it worked. He watched a Sherman equipped with Cullen's fork punch through 3 hedgerows in 5 minutes without taking fire. He asked how long it would take to equip an entire armored division. Cullen said 3 days if they had enough steel. Bradley pointed to the beach obstacles. Thousands of tons of German steel, hedgehogs, gates, tetrahedrons, and stakes, were rusting in the surf along Omaha and Utah beaches. He told Cullen to take whatever he needed. Within 72 hours, ordnance shops across the beachhead were cutting and welding. Portable forges were set up in bocage fields. Acetylene torches hissed day and night. The device acquired a name, the Rhino. Not official, not formal, just what the crews called it. The name came from the prongs, 4 tusks jutting forward. Aggressive, unstoppable, a battering ram that turned a Sherman into something more dangerous. By the end of June, nearly 500 Shermans had been fitted with Cullen's hedgerow cutter. But the device was only half the solution. The other half was mines. The Wehrmacht had sown the bocage with teller mines, shoe mines, regals, and improvised explosives. Some were metal, some were wood or glass or ceramic. All were pressure detonated. A Sherman weighed 30 tons. Step on a mine and the blast could shear a track, a bogie, or, if the mine was large enough, blow the floor out of the hull and kill the driver. Teller mines were the most common. Circular, 10 inches in diameter, packed with 12 pounds of TNT. They were designed to destroy tank tracks. A teller mine detonated under a Sherman's track could snap the steel links like thread and immobilize the vehicle. An immobilized tank was a dead tank. Shoe mines were smaller, wooden boxes filled with half a pound of explosive. They were designed to maim infantry, but enough of them clustered together could damage a tank's suspension or road wheels. Regal mines were bar-shaped, 18 inches long, 20 pounds of explosive. The Germans buried them lengthwise across roads and trails. When a tank rolled over one, the pressure plate triggered a blast strong enough to tear the belly armor open from the inside. Mine casualties in Normandy averaged 12% of all tank losses during the first month. And the Rhino made it worse. When a Sherman rammed through a hedgerow, it was blind for 5 or 6 seconds. Dust, debris, broken branches, clumps of dirt flying. The driver couldn't see the ground ahead. The bow gunner couldn't either. If the field beyond the hedge had been mined, the tank would roll straight into it before anyone realized the danger. Engineers tried to sweep the fields before the tanks moved, but minesweeping under fire was slow and deadly. Probe teams averaged 15 yards per hour in contested terrain. 2 men with bayonets poking the ground inch by inch, hoping not to trigger anything that would kill them. In combat, that was too slow. Tank commanders learned to watch for signs: disturbed earth, unnatural patterns in the grass, tracks that stopped abruptly or changed direction. But signs weren't guarantees. The Germans were experts at concealment. A well-laid minefield was invisible until something detonated. Cullen heard the complaints from other tank commanders. The Rhino worked. It solved the hedgerow problem, but it turned every breakthrough into a gamble. You could punch through a hedge in seconds and hit a mine before you knew it was there. So he started thinking about a mine plow. Not a detector, not a prod, a plow. Something that would push the earth ahead of the tank and detonate mines before the tracks reached them. He wasn't the first to consider it. The British had experimented with rollers and flails since the North Africa campaign. The Matilda Scorpion, a tank with a rotating drum of chains mounted on the front, had been used at El Alamein in 1942. The chains beat the ground and detonated mines ahead of the vehicle. But flails were complicated. The drum was powered by a separate engine. The chains wore out or broke under sustained use. The entire assembly weighed over a ton and reduced the tank's speed to 2 miles per hour. And the noise was deafening. You could hear a flail tank from a mile away, which made it a magnet for artillery. Cullen wanted something simpler, tougher, something a crew could fix with a wrench and a welding rod. He sketched a design in early July. A wide steel blade mounted on arms that projected forward from the tank hull, angled like a snowplow, heavy enough to dig 6 inches into soil. The idea was that the blade would scoop earth, roots, and mines to either side of the tank's path, clearing a lane 8 feet wide. But he couldn't build it alone. He needed engineers. He needed calculations. He needed someone who understood structural loads and metal fatigue. He found them in the 739th Tank Battalion. Captain James Doane was an ordnance officer, 31 years old, mechanical engineer from Dayton, Ohio. Before the war, he had designed industrial machinery, lathes, presses, conveyor systems. He understood forces and tolerances and failure points. He had been tasked with improving field modifications to armored vehicles, and he had heard about the Rhino. When Cullen showed him the plow sketch, Doane saw the problem immediately. The forces involved were enormous. A blade that size driven into hard soil at 5 miles per hour would generate tons of lateral stress. The impact would travel back through the mounting arms and into the hull. If the brackets weren't reinforced, they would shear off. If the hull wasn't braced, the welds would crack. The entire assembly could tear free and leave the tank crippled. Doane spent a week calculating loads and stresses. He estimated that the blade would encounter resistance equivalent to 12,000 pounds of force during a typical breach. That force would spike to 20,000 if the blade hit a buried stump or rock. The mounting had to withstand those peaks without failing. Then he and Cullen built a prototype. They used a salvaged bulldozer blade from a destroyed Caterpillar D7 tractor. The blade was 7 feet wide, 3 feet tall, made from 3/4-inch steel plate. They cut it down slightly to reduce weight. They welded mounting arms from 2-inch steel tubes salvaged from German bunker reinforcements. They bolted the assembly to a Sherman's lower hull using existing tow hook points and glacis plate holes. The prototype weighed 870 pounds, twice the weight of the Rhino, but the Sherman could handle it. The M4's 4GA engine produced 500 horsepower at peak output. Even with the added weight, the tank could still reach 25 miles per hour on flat ground. The first field test was conducted on July 8 near St. Lo. The tank entered a known minefield at walking speed. The plow bit into the soil and pushed forward. Dirt piled up on either side of the blade. Then a detonation, loud, sharp dust and smoke. The mine had gone off 3 feet in front of the tank. The blast threw soil into the air but didn't touch the hull. The crew felt a shudder through the deck, but nothing more. No damage, no casualties. The tank kept moving. Over the next 30 minutes, it triggered 4 more mines. All detonated ahead of the plow. None damaged the tank. The blade itself showed scorch marks and minor denting, but the structure held. The test was a success, but Doane knew the design had flaws. The plow was rigid. If the tank hit a rock or a stump, the blade could jam, or the mounting arms could buckle. And if the soil was too soft, muddy, or sandy, the blade would dig too deep and bog the tank down. The driver would have to reverse, adjust, and try again. That meant wasted time and wasted fuel, so he redesigned the mount. Added compression springs salvaged from truck suspensions, made the blade height adjustable using a simple screw jack, reinforced the arms with gussets and cross-bracing. The revised version weighed 920 pounds but was far more versatile. By mid-July, the mine plow, later designated the M1 dozer blade, was ready for mass production. But production took time, and Operation Cobra, the breakout from Normandy, was scheduled for July 25th. Bradley wanted every available Sherman fitted with either a Rhino or a mine plow before the offensive began. Ordnance units worked around the clock. Foundries in England shipped blade assemblies across the channel on LSTs. Welders worked under tarps and thunderstorms. Supply officers scoured depots for scrap steel, hydraulic jacks, and mounting hardware. By July 24th, 1,100 Shermans in the First Army had been modified. 600 carried Rhinos, 500 carried plows, some carried both. Not enough to equip every tank, but enough to lead the assault. Operation Cobra opened at 09:38 hours on July 25th, with the largest tactical bombardment of the war. 1,500 heavy bombers, B-17s, and B-24s dropped 3,400 tons of high explosive on a rectangle of ground 5 miles long and 2 miles deep south of St. Lo. The earth shook, trees vanished, craters opened. German defenders who survived the bombing emerged dazed and bleeding, ears ringing, lungs full of dust. But the hedgerows remained, and the minefields remained. The bombers could crater the ground and collapse bunkers, but they couldn't clear vegetation or detonate every mine. Some explosions triggered mines. Many didn't. The bocage absorbed the bombing and waited. When the Shermans rolled forward at 1100 hours, the modified tanks were at the front of every column. Rhino-equipped Shermans punched through hedgerows without pausing. Plow-equipped Shermans cleared lanes through minefields, leaving trails of detonated mines and churned earth. Behind them came waves of unmodified tanks, half-tracks, infantry, and supply vehicles. The German defense fractured within hours. Panzer Lehr Division, one of Germany's elite armored formations, had been positioned directly in the path of the bombing. 90% of its personnel were killed, wounded, or rendered combat ineffective by concussion. The survivors couldn't hold. They fell back in disorder. The 2nd Armored Division advanced 6 miles in the first day, twice the daily average for June. The 3rd Armored Division broke through German lines near Marigny and drove into open country beyond the bocage. By nightfall, American tanks were operating in terrain they had been trained for: rolling farmland, decent roads, long sight lines. The hedgerows were behind them. By July 30th, American tanks were 20 miles beyond the bocage. The breakout was complete. Patton's Third Army, held in reserve for weeks, was unleashed and began racing south and east. Resistance collapsed. The German 7th Army began a fighting withdrawal that would end in encirclement at Falaise 3 weeks later. Casualties among tank crews dropped sharply during Cobra. In the first week of the offensive, Sherman losses fell to half the June rate. Mine casualties dropped by 60%. Crew survivability improved because tanks weren't getting stuck on hedgerows or immobilized in kill zones. The Rhino and the mine plow didn't win the battle alone. Artillery, air support, infantry coordination, and German exhaustion all played roles. But the modifications made the battle winnable. They gave the tanks mobility, and mobility in mobile warfare was everything. Cullen's welded fork became standard equipment for the rest of the European campaign. Thousands were manufactured in depot workshops and issued to armored units in France, Belgium, and Germany. The mine plow was refined, mass-produced by ordnance battalions, and deployed to nearly every armored division in the European theater by September 1944. Neither device was glamorous. Neither appeared in newsreels or propaganda films. They were tools. Practical, unglamorous, the kind of innovation that soldiers respect because it keeps them alive. Curtis Cullen received the Legion of Merit in August 1944 for his contribution to armored warfare. The citation was brief. It mentioned ingenuity and initiative but didn't go into detail. He was promoted to technical sergeant. He served through the end of the war, mostly training mechanics and supervising field modifications. He never spoke much about the hedgerow cutter. In interviews decades later, he described it as common sense, something anyone might have thought of, just scrap metal and a welder. He deflected praise, said the real heroes were the men who used the device under fire, but the men who used it knew better. The Rhino wasn't a super weapon. It didn't revolutionize tank design. It didn't change the fundamental nature of armored warfare. It didn't make headlines or win medals for most of the crews who relied on it. But it saved time. And in war, time saves lives. When a tank could breach a hedgerow in 30 seconds instead of 3 minutes, it spent less time under fire. When it could clear a minefield without waiting for engineers, it kept the offensive moving. Speed and momentum mattered. They reduced casualties. They exploited breakthroughs before the enemy could react. By the time the Allies reached the Rhine in March 1945, Sherman tanks had been fitted with dozens of field modifications, sandbags for extra armor, logs chained to the hull for traction in mud, spare tracks welded to the turret for additional protection against Panzerfausts, concrete poured into hull gaps to reduce spalling, and always, when the terrain demanded it, a rhino or a plow. None of these modifications were designed by generals or engineers in distant factories. They were born in the field, made by soldiers who knew what worked and what didn't, men who saw a problem and fixed it with whatever was at hand. The U.S. Army's approach to tank warfare was fundamentally different from Germany's. The Germans built technically superior tanks, the Panther, the Tiger, but they were expensive, complex, and difficult to repair. A broken Tiger often had to be abandoned because spare parts weren't available or the repairs required specialized tools. The Sherman was the opposite: simple, reliable, easy to fix. And because it was simple, it could be modified. Crews and mechanics adapted it constantly. The tank that landed at Normandy in June was not the same tank that crossed the Rhine in March. It had evolved, improved, adjusted to the lessons learned in combat. That adaptability was a strategic asset. It meant that problems could be solved quickly without waiting for bureaucratic approval or factory retooling. A sergeant with a good idea could change how an entire division fought. The hedgerow cutter is a reminder that wars are not won by technology alone. They are won by the people who adapt technology to reality, who take a piece of scrap iron and turn it into a solution, who understand that good enough today is better than perfect tomorrow. Curtis Cullen wasn't a genius. He was a sergeant with a welder and a problem. But he understood something fundamental about how things break and how things work. He saw the Sherman's weakness and turned it into strength. The mine plow was the same. It wasn't elegant. It was heavy and crude, and sometimes it broke. The blade bent. The springs wore out. The mounting bolts sheared. But it could be repaired. And when it worked well enough. In July 1944, that was enough. By the end of the Normandy campaign, Allied forces had advanced 150 miles from the beaches. They had liberated Paris on August 25th. They had driven the Wehrmacht back to the German border. And they had done it with tanks that could cut through hedgerows and clear mines without stopping. Thousands of Shermans were destroyed during the campaign. Thousands more were damaged and repaired, but the casualty rate, measured in crew deaths per tank lost, declined steadily after June. Part of that decline was due to experience. Crews learned to fight smarter. They learned to use terrain, to coordinate with infantry to watch for ambushes. Tactics improved as lessons were absorbed and passed down. But part of it was due to men like Cullen, men who saw a gap between what a tank could do and what a tank needed to do, and closed that gap with ingenuity and steel. The legacy of the hedgerow cutter extends far beyond Normandy. It set a precedent. It proved that field modifications could be as important as factory designs. It showed that soldiers, not just engineers, could innovate under pressure. In Korea, American tanks were fitted with dozer blades and mine rollers based directly on Cullen's work. The M4A3E8 Sherman, still in service in 1950, often carried a blade assembly derived from the Normandy mine plow. The doctrine of rapid field modification became standard practice in Vietnam. Armor units modified vehicles constantly. They added gun shields, changed weapons mounts, reinforced hulls with applique armor, installed smoke dischargers. The culture of field innovation had become embedded in U.S. armored doctrine. And it began with a sergeant in Normandy who welded scrap iron to the front of a Sherman and turned it into a hedgerow eater. No one laughed after that. The numbers tell the story clearly. In June 1944, the First Army advanced 10 miles in 24 days at a cost of 766 tanks. In the first week of July, after the Rhino and Mine Plow were deployed, the same army advanced 50 miles in 6 days with losses cut nearly in half. Casualty rates dropped, tank losses dropped, the pace of offensive operations accelerated, and the breakout that had seemed impossible in mid-June became inevitable by the end of July. Curtis Cullen went back to welding. He was promoted to technical sergeant in August. He trained other mechanics in the use and installation of field modifications. He supervised workshops. He never sought recognition or publicity. He never wrote a memoir. When the war ended in May 1945, he returned to the United States and settled back in New Jersey. He worked as a machinist for nearly 2 decades. He married, raised a family, lived quietly. When people asked about his service, he mentioned the 102nd Cavalry in Normandy, but rarely talked about the Rhino. He died in 1963, 52 years old, heart failure. His obituary in the Cranford Chronicle mentioned his military service and his Legion of Merit, but didn't mention the hedgerow cutter. Most of his neighbors never knew. The invention outlived him by decades. Hedgerow cutters remained in U.S. Army inventory through the 1950s. Variants were tested in Korea and found effective in broken terrain. The concept, using a tank's mass and momentum to clear obstacles, became foundational in combat engineering doctrine. Modern mine plows are direct descendants of Cullen's design. Heavier, more sophisticated, hydraulically adjustable but built on the same principle. Push the danger ahead of you. Clear a path. Keep moving forward. The Sherman itself became a symbol, not of American industrial power, though it represented that. Not of technological superiority, though it had strengths, but of adaptability. The tank that could be modified, repaired, and improved in the field. The tank that soldiers trusted because it didn't quit. And part of that trust came from men like Curtis Cullen. Men who didn't wait for orders or approval. Men who saw what needed doing and did it. War is often described in terms of grand strategy and decisive battles. Historians focus on generals and politicians, on turning points in campaigns, on the movements of armies across maps, but wars are decided in hedgerows and minefields. In the moments when a tank commander has to choose between advancing blind or stopping under fire. In the seconds after a mine detonates and the crew realizes they're still alive. In the decision to weld a piece of scrap iron to a hull and see if it works. Those moments don't make it into most history books, but they shape outcomes. They determine whether an offensive succeeds or stalls, whether crews survive or burn, whether a battle is won in days or weeks. The Rhino didn't win the Battle of Normandy, but it helped. And in a campaign where every advantage mattered, where every hour counted, where every life was precious, that was enough. Curtis Cullen understood that. He didn't build the hedgerow cutter to be famous or celebrated. He built it because men were dying. And he had an idea. And when the idea worked, he moved on to the next problem. That quiet pragmatism is the real story. Not the invention itself, but the mindset behind it. The willingness to act without certainty, to build without blueprints, to trust that a good answer today is better than a perfect answer tomorrow, to solve the problem in front of you with the tools at hand. The Sherman tanks that rolled through France in the summer of 1944 carried that mindset with them, welded to their hulls, bolted to their frames, forged from German beach obstacles and American ingenuity. They laughed at his welded plow until it turned a Sherman into a mine-eater, until it cleared the hedge and opened the road to Paris. Then they stopped laughing and started welding.